Okay, for our final thing today, we're going to use these divisibility rules to help us find the greatest common factor of two or more numbers. So starting off here, we've got two numbers, 390 and 990, and we're supposed to find the greatest common factor for these two. So what we're going to do is find the prime factorization for each of them. So I'm going to start with 390. Just going through my list again, since I want a prime factorization, I want the largest number possible that I can divide it by. It ends in a 0, so I know immediately it's going to be divisible by 10. So I'm going to start with that. And dividing by 10 is pretty easy, so I'm just going to do that part in my head. So 39 times 10. And then the 39, I can tell that that's divisible by 3, because 3 plus 9 is 12. So this would be 3 times, and then just thinking about it a little bit, or maybe doing the long division, I can see that it's 3 times 13. So the 10, I'll go ahead and break down into 2 times 5 as well. Now I'm going to do a prime factorization for the other number. So looking at 990 now. Same process. I want to find the largest number possible first. So since it ends in a 0, I know it's divisible by 10. And that would give me just 99 times 10. Again, that's a pretty easy one, so I can just do it in my head. Okay, now 99 is a nice number also. Any two-digit number that you have that just repeats itself, like 99, 88, 77, those are all multiples of 11. So this is 9 times 11. And the 10 I can write as 2 times 5. And then the 9 I can break down again. So this would be 3 times 3 times 11 times 2 times 5. Okay, now for the greatest common factor for these two numbers, I need all of the factors that they have in common, and as many of them as they have in common. So if I see a 3 over here, and there's also a 3 over there, then I can write down 1, 3 for my greatest common factor. I'm going to do that for each of the factors in one of the numbers. So the next number I see is 13, but there is no 13 over here, so I'm not going to underline that one. I see a 2, and there is a 2 over here, so I'm going to underline that one and write it down. 1 because it happened in both of them. I write down 1, 2. And then there's also a 5 in both of them, so I'm going to go ahead and write down a 5. Then when I state the greatest common factor, I made it through the entire list on one of them, and I compared it to the other list, so I don't need to go backwards. That takes care of everything for me. All right, so now I just need to multiply these together. So 3 times 2 is 6, times 5 is 30. So the greatest common factor for these two is 30. Now looking at the second one, I've got 459 and 3,672. So I'm going to do the same thing for this one. I'm going to find the prime factorization for each of the numbers, and then I'll compare the lists and pull off the ones that they have in common. So starting with 459. Let's see, I want the largest number possible. This time it doesn't end in a 0, so I can't use 10. I'm going to try 9 next. So if I add the numbers, 4 plus 5 is 9, plus 9 is 18. It is divisible by 9. I'm going to say 9 times something. So I need to figure out what the something is. So I'm going to go do a little scratch work. So 9 will go into 45 5 times with nothing left over, and that leaves a 9. So it's 9 times 51. All right, now 9 and 51 are a little bit more reasonable. 9 I can break down, 3 times 3. And 51, if I add the digits of that number together, I can find pretty easily that it is divisible by 3. So I would just have to figure out 3 times what. So 51 divided by 3 would be 17. So I've got 3 times 3 times 3 times 17, and that's going to be 459 there. Next up, we're doing 3,672. Okay, so I do want the biggest number possible. 10 is not an option because it doesn't end in a 0. So I want to try 9 next. So 3 plus 6 is 9, plus 7 is 16, plus 2 is 18. It is divisible by 9. So I want to see 9 times what? So again, I'm going to do a little division out to the side. Okay, so 9 will go into 36 4 times with nothing left over. It brings down a 7. 9 won't go into 7, so that's a 0. Bring down the 2, and I've got 72. 9 will go into 72 8 times. So this is 9 times 408. Okay, so next up I need factors of 408. Okay, I can tell that 408 is divisible by 4. And that's actually kind of some easy division. So 4 times 102. I'm going to go ahead and write that down. Now I need 102. And let's see, this number, if you add the digits, you get a 3, and it ends in a 2. So that means I know it's divisible by 6. So I think I'm going to go by 6. So 6 will go into 10 once. And then 6 will go into 42 7 times. So now I've got 9 times 4 times 6 times 17. And now we're down to reasonable numbers, so I could break this down pretty easy. So this would be 3 times 3 times 2 times 2. Oops, that looks like it says 22. I didn't mean that. 6 is 2 times 3, and then 17. And so now I'm ready to compare the two lists so that I can find everything that they have in common. My first list, there is a 3, and it will match up with one of the 3's on the second list. So I'll record it. First list, there's another 3 that matches up with another 3. So I'll record that one also. The first list, there's another 3, and that matches up with another 3 over here. And then on the first list, there's also a 17, and there's a 17 over here. And I used up all the numbers on the first list. So I would just need to multiply all of those back together. So when I do that, since this is all the numbers on this first list, I would actually just end up with the original number I started with. So 459 is actually the greatest common factor of these two numbers. Okay, so now you've got 2 to try down here. And then we'll do some practice on this on Monday.